On logic, what I'm familiar with, and maybe I should start with that, is predicate logic, which is conjunction, disjunction, usual. And there's many variants of that, because there's many variants of valuation of truth. Modal logic, fuzzy logic, intuitionistic logic, paraconsistent logic. But what they always have in common is basically rules of inference. It's saying when you have this pattern of predicate, here is the next pattern you can derive from it. So that's, it's not so much formula in the sense we've been doing it exactly, but kind of, in a way it is. It's the inference rules are kind of predicate factories. And the beauty of those predicate factories is that they're deterministic in the sense you can check whether given claim is a proper application of certain rules, certain premises. And that's certainly a property I would like to conserve, saying this inference rule, you can prove that this is what comes out of it, and no, it's not a misapplication of the rule. Maybe the rule is wrong, maybe all kinds of things, but it was applied properly, and that's checkable. And that's certainly, again, a benefit of canonicality. And I don't know that what is interesting when you introduce heuristics is that and I think we shouldn't introduce heuristics, is that you can have rules which are properly applied, but whose result is less certain than the premise. But it still is support.
Can you repeat that, please?
Yes. When you have heuristic rules of inference, you have a rule which is properly applied, and yet the conclusion is less certain than the premises, because that's built into that rule of inference. That's not an absolute rule, that's a heuristic. So there's an intrinsic uncertainty on the conclusion.
Yeah, there's that seems to be a different version of this argument only partially applies type of issue, where your support isn't 100% when you're trying to measure strength. This goes into scoring, but it also goes into intuition that, yeah, this is related to what we're talking about, but it doesn't prove the outcome. And I would rate this as like moving my opinion this much, right? So there's kind of that's why scoring I think scoring has to come into it at some point, right? People do it in their head. Okay, you could do it in your head, but yeah, it's the same sort of thing where, okay, this study is interesting, but it doesn't fully apply.
Yeah. And actually, the question about this, what's interesting in that case is when you have a heuristic, is to have the potential defeaters, right? That's what the Walton's work on argument schemes gives us. We're using this scheme, so this would be kind of a more absolute proof unless this. So if we can eliminate those confounding factors, then it becomes a more solid proof. It's maybe not absolute yet, but more.
Yeah, I don't, I haven't studied inference schemes. I started to understand them better when I read up on, what is it, AIF?
AIF uses the first list of inference schemes in Walton. The inference scheme, his inference scheme thought has evolved a lot. I used the book as a basis, and it's the second set, and that hasn't been as well formalized yet, unfortunately. But beautiful, beautiful work on identifying points of the feasibility of different inference schemes.
Back to the heuristic thing. I'm wondering, isn't support something like I'm still.
It is.
That's what I'm saying. Yeah,
what
it
support
is.
Yeah. Okay.
Yeah. I'm saying like support is very generic, and an inference scheme would classify, categorize, and organize this in a much more structured way, right? So whereas I guess the example I saw in AIF was appeal to authority type thing, where authorities are actually recognized as having valid arguments in law, like in for example court cases. There's a set of rules that state, okay, it's an appeal to authority, their arguments, right? But how valid is that authority? And sure, you could do it totally informally and just say, yeah, but they don't work in that area. Or, I saw some other papers they had and they obviously show bias in that or whatever. So those are kind of informal arguments that you can have. But in terms of court cases, it's structured around some check marks, right? Of, is this person an authority in the subject upon which they are discussing? And, is their level of authority, are they certified under certain things? And so there's check marks you have to have in order for it to be considered a valid inference, at least under court law, right?
And it's valid to do so. Like there's moments where argument by authority is valid. I mean, of course, that there's moments where it's invalid. It's a heuristic.
Right.
And yeah, heuristic, the thing about heuristics is they're not always right and they're not always wrong. Saying this is not proven doesn't mean it's false. So let's go back a bit, because what I'm hearing, and this is hugely interesting to what we're saying, is do we want every support to be backed by an argument scheme? For me, this is actually a great case of a separate layer, separate domain, sorry to use Stevens. The saying these premises support this conclusion can be done informally, and we can say, oh, by the way, we know it works because it's a proper application of this inference scheme, right? That would be perfectly appropriate to have a separate domain.
Yeah, I have a problem with this concept of having it in a separate domain. Like I see it in a separate domain in terms of like a separate set of use cases, or what is the so that's right. That makes sense, and that helps us categorize our discussion of the things, or the
Yeah.
But I run into a problem with, I can't picture the simplest fundamental model that should be used by everyone working without including it. Because if you are going to take in arguments and structure them according to a specific heuristic structure, there's no way to represent it in the simpler model. There's no way to map from one to the other, for example, unambiguously without encoding it into the simpler system, basically.
Like the coding mechanism itself is a mapping.
Yeah.
Like sometimes you can do that.
But it gets to the difficulty that just because a claim, if let's say that the most fundamental model is only the informal structures, right? And then you're going to have a second layer that's storing these things in the more formal structure. My question is, are you creating claims or arguments which will get lost in the fundamental, in the base structure? Like, how does that work in terms of, I'm going to create an argument here that is an argument by authority according to this heuristic, and show that it's a valid argument by authority. And I'm going to enter all the elements here that show that, right? And those elements are going to be things like this person is certified under whatever, This person, their domain expertise is in with this realm, and the realm upon which their argument exists matches their realm of expertise. So you've got these different claims. Okay, you've got those claims, but the connectors within those claims, like how does it work that you create it in the one system and it maps it into the base structure and maintains that mapping? That's
I see your worry. I'm trying to think about it, and I'm not 100% either way. I suspect you're right, but I'm trying to think, okay, we have the basic, and I just brought it back for the heck of it. We have the basic notion of support is between claims and premise and conclusion. And this one has the compound claim version, and it doesn't have multi-argument, and I'm still wavering on that one, but let's not go there. And the question is, could we have scheme as, the support has or doesn't have a scheme? There would be a bidirectional link between, here's the scheme that was used for this support. And where it gets problematic is that for it to work, the question is, can you do it without duplicating everything underneath? Do you need to have extensions of everything? And I suspect yes, because one thing you need is in the compound claim, for example, you need variable unification. Like if each claim is a predicate, this thing has, this table is blue and this table is made of wood and this table is this and this table is that, those are different claims. And when you make a compound claim, you're talking about the same table in every claim of the compound, which may or may not be the case. Maybe it's this table is blue and that table is made of wood. So you need, whenever you do a compound, you have to have variable unification. That's part of the logic structure. And I used to be surprised with how much renaming variables was whenever we did inference schemes in mathematical logic, we spent a huge amount of time of, oh, and by the way, you can rename a variable, and that's an important, complicated step. And it's like, why? Renaming a variable is, you're just changing a name. But I realized, no, it matters because of variable unification. Are you speaking about the same entity between this predicate and that predicate? That's hugely important, actually. And if you haven't built that into the compound claim, then you're certainly re-adding it in the next layer, and that means the next layer has to have all the information in the base layer, and that's wrong. Which is, I think, is what you were saying, right? The question is, does the separate domain have to re-encode everything in the base domain? Then you've drawn your boundary wall.
Yeah, I'm thinking through this. I think one thing that Felix said kind of helped me with this. We could, the only way I think to have a base layer and then a separate layer for these added formalities or whatever is if you have a very clear mapping of the more formal to the base layer, to the basic, right? And then you have to, and I think it has to be a one-way mapping, or rather, it doesn't have to be, but I think it has to be acceptable that we only have one-way mappings, because just like we don't expect to be able to develop systems that can automatically read a person's claim and reverse it into the more formal structure. How do I say correctly?
Or at least that's a huge project and not in scope.
Well, yeah, I mean, it's being done by Project Debater and all that, right? IBM's doing it. But like, I don't think it really serves the purpose. You can do it, but we want that result to be debatable. Right. And so while it can be done, it can't be automated and considered finished and accepted, right? I mean, we plan on using NLP for other things too, maybe to auto suggest definitions and so on and so forth. Yeah, we're going to use it, but not.
We don't want to have it as a
trust it.
requirement for the system working well.
We don't want to trust it. Let's just say that. Yeah.
That sounds perfect.
Yeah. Okay. So, but then I think the exercise that needs to be done with each question of, is this a separate domain or can it be in a separate domain, is, can we come up with an unambiguous mapping to the base structure? And there's a separate question, which is, you know, what do you do about, because if we have incremental formalization, how does that work? Because if you have like an informal version of a claim and a formal version of a claim, and they weren't made in the same place and at the same time, then like if someone comes in and formalizes something and maps it into the base layer, are we creating a lot of duplication in the base layer and confusion for the base layer? Maybe not. Maybe it's like, you know, if you're doing the formalizing after the informal's been there, then you are using the claims that were there, so you're not going to spit out that same claim. But sometimes the formalization requires moving things around, and if you're moving it around in your formal layer,
what do you mean by moving? I don't get it.
Like, well, I would have to come up, this is where I'm thinking abstractly. So I'd have to come up with a concrete example. But like, if you think about the mapping of a compound claim, for example, of essentially what you're doing is you're creating a structure that comes in between some claims and the things they're supporting, or, you know, you're essentially breaking a link, a direct link that was there before. And according to your structure, do you need to perhaps bring in things that in the informal structure are linked in a different place, and you move them under, in other words, by formalizing, does the mapping back to the thing not match the way it is in the base layer? Okay.
I'm not sure. Let me translate and tell me if I'm talking about something else, because I might be. It's always been obvious to me that when you're formalizing, you have the informal claim, you have the formal claim, they coexist, and you're making a claim that this formalization, this formal claim, is a proper formal interpretation of the informal claim. And that itself is a claim and can get contested, blah, blah, blah. But if it goes uncontested, and that's the conversation we had the other day, if it goes uncontested long enough, we can say, okay, it's good enough, and we can now replace the informal claim in all the references to the informal claim by references to the formal claim, saying, well, the community is accepted, and accepted until a better one is proposed, right? Until someone says, actually, this informal claim should be replaced, this formal claim should be replaced by this other formal claim, because it's a better formalization, because it's clearer, because this, because that. And this can be based on the informal claim or not. I mean, we can just replace a formal claim by another because there's an added presupposition that wasn't seen at the time, but it's intrinsically necessary to the formal claim, even without reference to the informal claim. But this notion that, on the one hand, we want to replace, that's one thing. The replacement can be contested. No, you didn't formalize it right. So that means they have to coexist, and the replacement is a claim. For me, that's always been obvious.
Yeah, I disagree with those claims or those points in some cases.
They add complexity because it creates a problem of grounding. But my point is, they seem okay. I don't see how they're avoidable. How do you think you'll avoid A, the coexistence of the formal and informal, B, the possibility of contesting the formalization?
Okay, so there's a couple different things I want to
Go ahead.
tackle. But first of all, I disagree that there's necessarily a need to agree that a formalization is a proper formalization of a previous claim, because again, I take
But
a
that's
sort
not
of
what I said.
stateless approach.
I said you can contest it. I didn't say you have to agree with it.
No, you can, yeah, I'm saying maybe maybe I don't see value in contesting it.
Okay, that's easy
Um,
too. You don't see value in contesting it? You don't think like, okay.
No, because
No.
wait. Remember, I don't, when we talked about disambiguation, which is definition or whatever, you know, even using the term disambiguation, we got into trouble. But the process that we've been calling disambiguation, right, where essentially you're adding disambiguations to a claim to specify more, right?
Yep.
And we bring up the question of, is that a valid disambiguation of that statement, of that claim? I've said many times, I don't think it's important whether or not it is or not, because what you're doing is you're creating a new claim by disambiguating it. And whether or not that claim is true or not, and whether or not it's a valid supporter of something, are all you need. You don't need to know if it was a proper disambiguation of something else, because you're not, it's not what somebody said and you're trying to figure out what they meant. It's, here's a claim. Is this claim true or false? And I can create 100,000 variations of the same claim, and we could talk about each one of them, whether or not they're true and false. And it doesn't matter which one is the best match for the original claim, because each one, if it's true, and if it's a valid support of something, that's interesting. I don't care if it was the proper interpretation of something or not. I just care about, oh, here's a true claim that's a valid support of some other claim.
Yeah, I see. I think I see what you're saying, and though at some level I disagree, because that's a matter of
right. It's a long, yeah, it's a long-term
but,
disagreement we have. Yeah.
Yeah. And it's not one that and I think it's one where we should agree to disagree, because basically we have different use cases, which is,
I think so. Yeah.
That I don't think that's productive. What I think is important is I can totally see a use case, which I'm sure you'd agree on A was claimed to support B, A was informal, and then you have multiple interpretations of A, disambiguation or whatever, and then which ones still support B? You want to replace A, like, it makes sense for some of them to support B and not others. So you want to refine the support, say, well, actually, the one of those interpretations that makes sense in that support relationship is this one.
Right.
And that way it is the proper interpretation of the informal claim in that context of that support.
Correct. And that can be done with the most basic form of the model, as long as the base model includes disambiguation. Because if you don't have disambiguation, how do you have multiple forms of the same claim?
Exactly.
The question.
But what I'm saying next is, at that point, it becomes interesting to look at the informal claim, the informal claim, look at all the supports it's involved in, and see, do the same operation. Like, okay, is there, does it work as a, do all the interpretations work as support in those supports, and which ones do and which ones don't, and do we do those replacement? Which is exactly which is exactly the operation of replacing the informal by various more formal and distinct more formal. That's what I'm talking about when I say let's replace it.
No, okay, but I don't see that creating a new structure that needs to be maintained about the debate about whether or not one is more one is the appropriate interpretation. It's just about it. It's about whether each support is valid or not, which is a base model operation, right? But the other point, which is related and very important to consider, is each formalization, as you said, each new component that we add in there adds a new territory for debate. It's like the more meta version of what you're saying, or generalized version, is every new thing that we introduce creates new territory for debates. And here's the problem. We don't have this problem necessarily in the example that we're talking about, but in the case of whether or not this is the correct formula, or I don't know, we have to look through each individual case. The question is, does this formalization introduce a field of debate that would not occur in the base layer? Because if that's true, what you are creating is a debate for which there's no top node claim in the base layer. In other words, you're kind of orphaning in the base layer the debate.
Okay, I think I need to go through that again. I think I see what you're saying, but
yeah, I have to come up with. Let's say that we introduce. Okay, let's say this is how we do it for formulas, right? Let's say our formalization, which we do in a separate layer, a separate domain, right, is introducing a new element called formula, right? And so you use formulas to put together claims. So the question is there a mapping of formula to the base layer?
Which I'm
is
pretty sure
there a proper mapping? There might be, there might not be. I mean, I guess you could just map it to words in a claim. Does that do it or not? We'd have to look at the rest.
I would actually, yeah. I mean, whenever okay. In all the logic,
but let's just say let's say that wait let me finish the example, because I'm just trying to get at this other concept here, which is,
okay, cool.
So let's say our formalization approach introduces that you can propose within this object multiple formulas, and you're going to debate about which formula is the right one,
expresses the informal claim most accurately.
Yeah. So the question is, are you introducing a structure about which you can't debate in the base layer?
I think the answer is a clear no, or at least, I'm not saying it's, okay, it could be yes in theory, but I don't think it's yes in practice, in the sense that formula I expect will be based on existing logic systems. And all the logic systems I know, there's something called interpretation of the logic, which basically amounts to, can we rephrase that logic formula as a natural language sentence? And that's what is meant by interpretation. And there's always a process to do so. Because otherwise, nobody could introduce the logic if it could not be explained. And, it's in a book. Somebody explained it and explained the motivation behind that logic. So of course it can be rephrased as natural language. So I would say, yes, it's always possible to rephrase any logic formula as natural language and hence put it in the base layer, almost by construction. If it couldn't be done, then that logic could not have been introduced in an article.
Yeah.
It's not an absolute proof, but
yeah, no, I tentatively accept that. I accept it, and I'm waiting for us to get our hands dirty to see if, in other words, it's a question that is, I think we should ask ourselves with every mapping we create. If we create a formal structure and create a mapping, we need to think, does the debate about this also map into the base layer, right?
Yeah. Sounds right.
Yeah, I think this whole conversation is kind of the beginning of a new mode of operating and modeling for us, which would be, we've clarified. Oh, we propose this formalization model. Let's also propose with it what would be the mapping into the simple base layer.
Into a formula less.
Yeah.
That I'm happy with. the distinction between, is this a separatable domain, that I was trying to bring was a totally different basis, right? The one about, does it mean re-implementing the whole bloody base domain in the separate domain, which I think is a red flag.
Right. Yeah.
But I agree with that. Your distinction is also important. It's a distinct one and it has value. Are we?
I mean, I think what it does is it provides a way, again, like we when we first were having our problems about even which way to proceed in our discussions, right? We almost fell apart because we couldn't agree, and we found out that breaking it up into, you know, today's your day, today, right? We communicate so much better now. I think this is also one of those things where
Yes.
Stephen is very adamant about keeping a simple base layer and then creating separate domains as a way to organize and as a way to, you know, maybe we don't need all this. Why do we actually need this? And I think by doing it this way, it satisfies both sides, because we can always see, okay, here's the formalized structure, and here's how it works in the base layer. And then knowing that, we can evaluate, each person even could evaluate whether or not it's worth just building it into the base layer because it simplifies for everybody's minimum case, right?
Right.
But, you know, at the very least, we know we can do it in a higher layer and map it in. Yeah, I think that's.
Yeah, I think that's right.
That's good.
Progress. I'd like to come back a bit on the question of what does it mean to have the right interpretation, right? I think we found a good terrain of agreement with, do we need to revisit this informal statement with all the formal statement? The other thing I see is we're going to crowdsource. That means there will be semi-skilled people doing the formalization. And that means we'll have to say, you know, you didn't do it right. We will involve an LP, and as we said, an LP is not fully reliable. We'll want
so
to
that is like in our checklist of creating a formalization.
Right.
You know, we've got, what's the mapping to the base layer? Does it create the possibility for debates that don't map to the base layer? Probably never, but let's ask that question. And then the next one is, what happens when somebody does it wrong? What does that look like? And, you know, what would be the process for making it better, if there needs to be a process or whatever?
Yeah.
You know,
And this is why I'm saying formalization needs to be arguable. We need to be able to say, you know, somebody said that this informal claim maps to this formal claim. You know what? They did it wrong.
Right, but you know, I think just like there's always probably a mapping to the base layer for any formalization, there's also a solution to the debate, which is it a valid support? Right. I think you're probably going to see that it might not be the best solution. Again, it just like, you know, the base layer serves every case. It might not be the best solution for every case.
That's something we disagreed a lot on the previous the F equals MA case because you wanted to treat it. When I said this is a claim in its own right, and you said, oh, we'll see it when it's the support of something else, and I said no, I can disagree with it independently of it being the support of something else.
I still disagree with that, because I think you can disagree with a claim that is a statement of the result. You can disagree with a claim that is a statement of the result, which is like force equals 25 newtons. You can disagree with that.
Which is what I was saying.
But you can't disagree with 5 kilograms times 5 meters per second squared.
I agree totally with that. And what I'm saying is,
that's where our debate is it's in semantics. It's what we mean by you can debate it, right?
But I mean, I was very clear that I always agreed there is, and you know, we repeated it today even, that this is a proper application of the inference rule. It's computable, it's compute verifiable, right? And nobody should be able to argue with that. Now, but I did say, and then this yields a claim, which is a different, the outcome is a claim which is arguable. The outcome, like downstream of that inarguable result, we get a claim in its own right and independently of it being involved in something else, which is arguable. I can disagree with not this being the result, but I can disagree with the result and say, but you know what?
Correct.
This is wrong.
Yeah, yes.
Maybe we can look at it like we're looking at type checking. Like, if things don't fit, like, oh, this variable is an int and the other variable is also an int, so the multiplication result is an integer as well. And if I have a string there, then the type checker says, yeah, it doesn't fit, right? We can have something
There's
similar.
And I think this is yet another reason why I see that being a support relationship, right? In other words, the compound formula structure, instead of having equals C, the equals C being a claim that absolutely matches it, the equals C is really, the conclusion is C, it's a support, right? F equals supports the claim that the force is 25, right? Because I use this formula and I put these inputs. And so that supports the debatable fact that the force is 25, right? Which we agree that claim is debatable. And I think that the formula just supports that. Now, bringing it back to what you were saying, Felix, I've seen this pattern being interesting beyond formula. And that pattern is there a certain amount of automation that can be applied to the supports relationship? Because once you have disambiguation, if your premise, if we go back to the Paris example, right? If the claim has been disambiguated to be talking about Paris, the city, and the premise you're using to support that says something about that Paris is beautiful, but is using Paris, the mythical figure, in the premise, it's the same sort of thing. You have a mismatch of units where your unit essentially is your entities in the premise as compared to the entities in the claim. And so you can already see there's some sort of mismatch there in the supports relationship.
And this is what I call variable unification earlier.
Okay.
It's not a unit mismatch, it's a variable unification mismatch.
Where again, I think, I think that the disambiguated entities are variables of their own right, even if they're not
exactly
or whatever.
Yeah. But you have one predicate imposes certain constraints on the variable. The other predicate imposes other constraints on the variable, and it's the same variable. That's really important. We're talking about the same Paris, and this is why. It's only because we're talking about the same Paris here that there's a problem. If they were two separate claims about both Parises, they could coexist. But it's because it's the same Paris that the two claims become contradictory. And so variable unification matters a lot in this contradiction detection. To come back to what you were saying, Felix, I absolutely agree. And that's the whole dual role of, on the one hand, the inference rules creates a new statement, like seeing it as a crank that generates a new statement from previous statements, and seeing it as a constraint which can be that is multidirectional, and you can go, from the constraint to the premise, from the premise to the constraint, and it's not so directed. See, the crank is in one direction only from premise to conclusion, but if you view the resulting thing as a constraint system, you could actually decide that it's the conclusion that invalidates the premise. So it could go both directions.
Exactly, either way, and the human has to correct it.
Exactly.
Well, go ahead and finish your sentence, but okay. Yeah, thinking about units, like when we think about formula, like what you were saying about, oh, if it's not the same type, if it's a string or if it's a whatever, but not just string, if it's units, obviously mathematically, when you're doing science and, your result on one side has different units than the other, it's not compatible. You see that a lot in missing premises, and like the lockdown example actually has a place where we could highlight that, which is, you notice that the value of human life saved by the lockdown is worth more than the cost of the economy, right? In the end, you have to be comparing same units, right? And what you come up with, though, when people debate is, oh, I think we're going to save 1 million lives. I think it's going to cost $1 trillion. Lives and dollars are not the same units. So when you try to match these arguments and you see that the units aren't, what's going on there? You're missing a step is what you're doing, because what you're actually missing is, oh, okay, 1 million lives, and economists value a life at $10 million per life. And then you've got lives times $10 million per life. You cancel out the lives and you've got dollars, right? And so you would have to introduce an intermediate claim there that's like essentially a compound claim, doing the math, putting them together before you compare the economy to the lives, value of lives, right? And this is something I'm trying to highlight in my example debate
like
right now.
The generalization of it is constraints, as Makan said. Like types is one thing, ranges of numbers or units are other things, and it all boils down to the general concept of constraints. Like if the constraints don't match, then the system or humans can show there's an error, and humans have to change it until it matches or not. Like depends on, but it's okay to represent states that have mismatched. That's progressive formalization.
Yeah, exactly. And what the system should do, if we want to support all these formalized structures, is highlight the fact that you've got a mismatch. Essentially call someone in to, hey, what's going on here? Help me figure this out. Go ahead and you fix it, and I'll let you know if it looks fixed to me, right?
Yeah, that's what we want, absolutely.
Yeah.
It all can be done by humans, like in the first place. Like
absolutely
can be done by humans, and getting help from machines is a second step.
Yes.
Exactly. Yeah.
I'll agree. No, and this is the value of progressive formalization. But we'll have to go back to modeling, and I don't know what's your timing today.
I only got 10 minutes. I got a hard stop.
You got a hard stop. Fair enough. But
yeah,
I
me
think
too.
I wanted. It's fine. But I just wanted to say here what I was trying to show here, and I didn't complete this diagram, and I need to go at it again. And sorry, I didn't do it. But okay, so this is the abstract formula. There's this is applicable. This is the unarguable application of the formula to the premise and saying, okay, then we get this. But basically what I'm saying is there's the unarguable conclusion, which supports a specific claim, and it's a distinct, there should be a kind of a distinct claim object, which is, I don't know if we need another object in between, but what I'm saying is this the arguable claim, or is this, well, maybe this is the arguable claim after all, so it's fine. But what I'm saying is, forget this one. If this square didn't exist, I'd have to create it, basically, because the unarguable part has to lead to an arguable part, which is
right.
The arguable claim. This is what happens in reality. Now, in this case, maybe the arguable claim pre-exists, which is fine. Here, definitely, I would have arguable. I certainly need something in between here, because this would lead to, the velocity would be so much, which objects to. So there would be the arguable result, which would be a distinct claim, which objects to this one.
Right. And this is why I said that compound claims aren't really claims, they're only premises. Because for one thing, I don't think you debate that that orange box, that beige box, right?
That was the point of making it orange, yes.
Yeah, I don't think you debate that. And so then what you have is, like you said, if you already have a claim there that you're supporting with it, then you go ahead and support it. If you don't, you're going to have to create it, right? Because otherwise it's pointless. It's not debatable and it's not being used for anything. It's just kind of sitting there in the ether. That is not a claim. It's not a claim because it's not to be debated, but it is a premise because you need some claim there to support.
Well, what I'm saying is I would say the not a claim part, the unarguable part should automatically generate a claim so that I can have a claim that I will use as a premise. It should be tied.
Right. What's missing there? Yeah, actually what's missing there in that supports, what we would want is that, no, well, yeah, the
and in this case, it's this
claim
one,
there.
but in
Correct.
the other,
Yeah,
but in the other
yeah,
case,
yeah.
I'd add a new one. Oh, I need to.
Right. You know, if there were a higher level thing we were debating, which is like the skydiver will be at terminal velocity after
Actually, I should just look at this one when I'm being silly.
I mean that one right there has all the components and nothing more, right? But if we had something else like the skydiver is gonna be falling fast, right? If we had something more vague like that. Right.
And this is
yeah. Okay, that's a perfect example right there. Yeah. Good.
And this is what I'm saying is this is a kind of autoclaim, and actually it's more than a support, and so is this. It just happens that the autoclaim coincides with the support.
Yeah. Because what yeah. Okay. Yeah, it's an autoclaim. It immediately falls into the problem we have with that leads us to design parameterized claims.
Yeah.
Because I'm going to now object to your autoclaim. Yeah. What is my objection? No, the velocity is 98 meters per second. In other words, you've created a loop, right? Which is what happens when you have a parameterized claim.
Yeah, well, like remember this line, right? I'm saying, oh no, you should use F2 instead of F1.
No, but I'm saying it's at an even higher level. The two claims, because they're mutually exclusive,
yes,
automatically object to each other.
Yes, okay, that's really interesting actually, because we have negation, but we didn't have the mechanism that says those claims are mutually exclusive even though they're not negative. And right. that's interesting because that's also a formula application, I would say. There's an inference rule that says these two are parameterized with different parameter value, hence with non-overlapping parameter values, because it could be a range, hence mutually exclusive. And that's a kind of formula application.
Yeah, I don't know if it's a formula application. It's definitely as with negation, it's just an inherent nature of the parameterized claims that each of those claims are automatically mutually exclusive of one another, right?
Yeah. Or again, we can define the overlap. If somebody says,
If it's an overlap, yeah, that's more complex.
but it's,
Yes.
it's a very interesting case, right?
But valid, yeah.
You're saying between 5 and 10, and I'm saying between 8 and 12. So the overlap is between 8 and 12, and we have an intersection. And the intersection of our two ranges becomes a new claim.
Right.
Anyway, we've reached a hard stop. I think this is definitely something to continue. I know we'll talk about UX tomorrow, but there's definitely something to continue there. I'm happy with.
Yeah,
where
I
we're at.
have to say, like, I think the compound claim approach is what I'm leaning towards, and I think the formula there is a form of compound claim, and I think I see that.
Yeah,
My conclusion is compound claims aren't claims; they can only be premises. Those are the. That's where I'm falling.
I'll think more about that. I'm falling towards we'll need both compound claim and multi-premise. You convinced me compound claim were necessary. I'm still convinced multi-premise is necessary, and we might need both. And that is a dog because it kind of hurts canonicality. So I'm still thinking that one through.
I already ran into this today as a problem with multi-premise in mapping out the debate in debate map, because debate map only supports multi-premise arguments, right? Like I said, Jamie thinks they're multi-premise claims because the way it's all organized and structured, but they're not. They're multi-premise arguments. And what I had to do was, exactly because of the example of, first you debate about the number of lives saved, and then you debate about the value of each life, and then you create a multi-premise, in this case, argument of the math that is the outcome, right?
Yep.
This times that is your multi-premise argument. And then you plug that into the other multi-premise argument that is A greater than B, right? Lives saved greater than cost. And what I wasn't able to do in debate map was I built the multi-premise argument for the value of the life saved, and I couldn't put it in as one of the premises for the A greater than B because it wasn't a claim. It wasn't a premise. It was only an argument, and I couldn't reuse it in the other structure because of that. So I had to create a duplication. Yeah, I'll show that later.
Sounds good. Yeah. This is the point I was making about we need the conjunctive normal form is actually a very, very fundamental construct.
Yes.
Yeah. It's not avoidable. Okay, excellent, folks. And see you Monday.
See you Monday. Good to see you, Bentley. I only saw your face show up here for a second. I don't know.
Tuesday. Did we move it to Monday or
Tuesday?
It's Tuesday. It's Tuesday.
Me
Yeah.
being confused. Sorry. Apologies.
No worries.
Yeah.
Yeah, I'm just lurking. But I have been watching all the videos, so
that's
fantastic. Great. Yeah, please.
Thanks everyone. Bye.
Thank you.
Take care.
Ciao, ciao.